Good day. I am Kenneth Bolima from B5B, and today I'll be performing laboratory experiment number 3, which is interfacing HMI to PLC, traffic light scenario, and water level scenario. So this experiment has two activities, the traffic light scenario and the water level scenario. So let's start with the traffic light scenario. First, let us create the ladder diagram for the traffic light that we will be using later on. We will be using RS Logic's micro starter light in order to create the ladder diagram. And we will be using the Micrologic's 1000 PLC. Now, first is we will be putting a normally closed stop button with the address of B3:0-1, and we will name it as the stop button. Then after the stop button, we will be using a start button with the address of B3:0/0. Start. Then after that, when we press the start button, the first light that would be lit up is the green light. So let's place a coil for the green light with the address of O:0/0, and it's for the green light. Now, once the green light turns on, there would be a timer for the green light, and it would be up to 10 seconds. So let's place a timer in parallel with the light. Timer on, delay timer with the address of T4:0, and let's name it as timer_green. The timer base is 1 second and the preset time is 10 seconds. Now we have a timer and an output for the green light. So let's put a latch for the green light to remain on until the timer reaches 5 seconds. So you normally open output address of O:0/0 for the green light. And then let's put a normally closed orange light, so that when the orange light lights up, the green light would turn off. But let's put it later. Now let's do the ladder of the orange light. So first, let's put a stop button, and then the orange light would lit up when the timer of the green light reaches 10 seconds. So let's use the address of the timer of the green light to start the orange light. 0/TN. And then after the timer green, we would place a output coil for the orange light, and with the address of O:0/1, and let's name it as orange. Now, in parallel with the orange light, we have the timer for the orange, and let's say that let's give the timer for the orange light the address of T4:1, and let's name it as timer underscore orange. Okay, time base of 1 and the preset time of, let's say, 3 seconds. Now we have the timer of the orange light. Let's put a latch so that the orange light would be kept lit until the timer reaches the preset value, which is 3 seconds. Let's place a normally open output for the latch with address of O:0/1 for the orange. And let's place a normally closed for stopping the orange light when the red light becomes empowered. So we can now put the normal close orange for the green light, which is O:0/1. And now let's do the ladder diagram for the red light. So like before, we would start with a normally closed stop button, and then now we will use the timer for the orange light so that we can lit up the red light once the timer of the orange reaches 3 seconds. So let's use the address T4:1. Now, after that, we will put a coil for the red light, which would be the address of O:0/2, and let's name it as red light. Like the other lights, the red light has a timer that would be parallel with the coil. So let's put a timer. Let the timer address be T4:2, and let's name it as timer_red. Time base is 1 and the preset value is, say, 5 seconds. Now we have a timer for the red light. Let's put a latch for the red light, and to do that we'd place a normally open and with the address of the output O:0/2. And in order for the red light to be turned off, the green light should be turned on. So let's put a normally closed with the address of O:0/0. Now we can place the off mechanism of the orange light, which is the red light, with the address of O:0/2. And in order for our system to loop, we would be using the timer of the red light to power up the green light once again. So let's add a rung for us to parallel a normally open red light. timer. So it's with the address of T4 colon 2. And for this we'll be using the DN /DN. Now we have the ladder diagram for our traffic light system. So let's download this to the PLC. Can download. Let's set. Then system comes let's see the systems. So let's download the ladder diagram onto the PLC. Oop, my error. Let's verify. Oh, we forgot to place a DN on the timer of the red light. So let's verify the ladder. No error, so we can download the ladder onto the PLC. Let's download. Okay. Yes. Let's go online. So we can test if our ladder is working by toggling this bit. So once we toggle that, as you can see, the green light is lit up and the timer is counting. Once it reaches 10 seconds, the orange light would lit up, and then after 3 seconds, the red light would lit up. And the red light, once it reaches 5 seconds, it would turn up and then empowers the green light, and the loop would continue. So let's implement this ladder onto the Wonderware in Touch, and we would be able to do that by, let's first turn up this PLC. Now let's open the KEP Server EX version 4.0 so that we can establish a connection with the PLC and the Wonderware in Touch. So let's create a new channel. Let's name it as channel_AB. Next, the driver for the Allen Bradley is DF1. And then the COM that we'll be using is COM3, and the baud rate is 9600. Then next, and then finish. So let's make a new device for the channel AB. Let's name it as Micrologics. Then click on next. The device model is Micrologics, which is the PLC that we are using, and device ID is 1. The next. Yeah. Now we can create the tags that we'll be using for the Wonderware in Touch. So first is the green light, and the address that we've used is O:0/0. Let's verify that, then apply. Then for the red light, let's name it as red. The address is O:0/1. verify it, and then apply. Then third is the orange light, which we use the address 0:0/2, verify it, and then apply. Next is the start button, start, with the address of B3:0/0, and then apply. And orange address 0:0/, the address for the red light is 0/2, and the address of the orange light is O:0/1. Now let's create a tag for the stop button with the address of B3:0/1, verify it, and then apply. And then let's make one for the red and green timer. So turn on delay green timer, the address of T4:0, then okay, then apply, then turn on delay timer for the red light with the address of T4:2, and verify that, and then apply. Okay, now we have all the tags that we'll be using for our Wonderware in Touch window. Now let's open the system management console so that we can use the tags that we've created onto the Wonderware in Touch. So let's make a new OPC object with the name of AB for Alan Bradley, and then the server name is the Kepware Kep Server EX version 4, and then let's save, and then let's add an OPC group object so that we can add the tags into the Wonderware in Touch. Update rate is 100, and let's name it as Micrologics. Browse OPC item, and as you can see here, we can view the tags that we've created with the Kep server, and highlight it all and then drag it down, then click OK and click save. Now we can create a Wonderware in Touch window using the tags that we have created. So let's create a new application. Next, HMI PLC. HMI PLC. Then create a window. Now let's create a new window, and let's name it as PLC. I mean stoplight. Size control, and then X location is 0, Y location is 0. Window width is 1366 and window height is 768. Okay. Let's make a stoplight using 3 circles. And Then let's make it as a black. Also, let's add 2 buttons for the start and stop. And let's put a counter for the red and green lights. See, stop. And 0 number. Punch. Let's just duplicate this. Yeah. Let's color this as green and this as red. So let's start placing the tags. So for the green light, we have fill color, discrete, and the expression is green. And if it's true, then the color fill would be green, and if it's false, it's black. Then let's create a tag name. The type is a IO discrete, and access name is, let's add, so AB for Allen Bradley. The application name is FS Gateway, and the topic name is AB underscore micrologics. Let's copy that and then paste it there. Click OK. Now we have an access name. The item name is the one that we have in the device items, which is the channel underscore AB dot micrologics green. Copy that and then paste it at the items. So click on save and then close. Okay. Now for the red one, the same as the green. This is for the orange light. So orange, and once it's true, it's orange light, and false when black. And let's define the orange tag name with the memory type IO discrete, and same access name AB, and the channel and the item name is channel underscore micrologics orange. Then save and close and OK. Now for the red light, it's the expression is red, and the color is, once true, is also red. Then define red. The type is IO discrete, and access name is AB, and channel is red. Then save and then close and then OK. Now for the start button, the touch link is a touch push button with discrete value. The tag name is start, and let's define the tag name, which is also an IO discrete type, and access name is AB, and the item is start. Now let's just replace this with the item name, then click on save and then close and then OK. And the same goes with the stop push button, which is a discrete value, and let's name it as stop. Let's define stop, and then the memory type is IO discrete, and the access name is AB, and item is stop. Then save and then close and then OK. Now for the counters, let's use the value display, which is analog. Then let's use it as TMR underscore green. Let's define that as a IO integer with the initial value as 0, minimum EU as 0, as well as the raw, and the maximum is 10 for the timer runs up to 10 seconds. Then access name is also AB, and the item name is the TON green. Let's use TON green. Save and close. Then okay. Then lastly, for the red timer, let's also use analog value display, that expression TMR underscore red, and a memory type of IO integer, and maximum EU is 5 seconds, and the item is red. Save and then close. Okay, so let's make the timer invisible if the light is not turned on. So let's do that by selecting the miscellaneous and visibility. The expression is green. Let's edit this. To make it count down instead of count up, we will be subtracting the TMR green expression to 10, and then the same applies with the red timer. 5 minus TMR red, and the visibility is red. Now let's overlap these two, and then let's test. We have a malfunction with the access name. Let's fix that. Yes, gateway. Okay, we forgot to activate the orchestra FS gateway, so let's activate that. And that's what causing our problem earlier. So let's see our traffic light system. Let's press start. As you can see, the green light turns on and the timer counts down. Then it switches to orange and then red, and the counter counts down as well. And as you can see, the PLC is also reacting to the program. Yeah, the first out is for the green light, then after 10 seconds the output 1 is for the orange light, and then output 2 is for the red light, and it's reacting simultaneously as the program. Yeah. That's all for the laboratory experiment number 3, activity number 1, which is the stoplight system. Tapos na.